Hello everyone, today we'll be going over lesson 9.1, which is dealing with finding square roots. When we talk about square roots, basically what we're saying is if we're looking at the example here, 36, what is the square root of 36? We're asking ourselves, what number can I multiply with itself, or square, can I get to 36? So in this case, for the square root of 36, the number that I can square to get to 36 is 6, right? Because 6 squared, or 6 times 6, equals 36. Now, if you're looking at the definition here up at the top, it says every positive number has a positive and a negative square root. So we already found the positive 6, but we can't forget about the negative either, because if I squared negative 6, that also gets me to 36. So I have two answers, positive 6 and negative 6, because if I square both of these numbers, they will get me to 36. So if we're looking at these three examples down here, the square root of 25 is 5 and negative 5, because if I square 5, I get 25. If I square negative 5, I get 25. Square root of 4 is 2 and negative 2. The square root of 100 is 10 and negative 10. That square root symbol is called the radical sign and is used to represent a square root. The number underneath the radical sign is called the radicand. There's three different ways we could show the radical sign. There's a positive, which is just the regular radical sign. There's the negative radical sign, which has a negative sign in front of it. And then there's the one that's asking for both answers, the positive and the negative, and that has a plus minus sign in front of the radical sign. So depending on what they're asking you for, you just got to look and see what type of radical they're giving you. If they want a positive answer, a negative answer, or if they want both positive and negative answers. We could also use radical symbols to find the square roots of fractions and decimals. So if we're looking at the square root of 4/25ths, what they're asking us to do is find the square root of 4 and find the square root of 25. Well, the square root of 4 is 2, because 2 squared gets me to 4. And the square root of 25 is 5, because 5 squared gets me to 25. So the square root of 4/25ths is 2/5. The problem on the right, we have the negative square root of 12.25, which gets me negative 3.5. Again, because if I square negative 3.5, I will get 12.25. Squaring a number and finding a square root undo each other. So they are inverse operations, just like addition and subtraction are inverse operations of each other. We can use this relationship to evaluate expressions. So if we're looking at the example here, the square root of 9 squared ultimately gets me to 9. The radical symbol and the square cancel each other out. Just same thing on the right. I have the square root of 9, and I'm squaring that, and that will eventually get me to 9. So the radical and the square cancel each other out. We can also solve equations and expressions with square roots. So if we're looking at this problem here, the square root, I want to take care of this square root of 25. Because right now the problem is 12 minus 3 times the square root of 25. So the square root of 25 is 5, because 5 squared gets me to 25. So now I have 12 minus 3 times 5. Well, 3 times 5 is 15. So 12 minus 15 equals negative 3. So my answer for that is negative 3. We can also solve algebraic equations involving squares and radicals. So for this one on the left, we have 7 times n squared equals 175. And this is just like balancing a normal algebraic equation. Our goal is to get the variable by itself. So I'm going to want to divide by 7 on both sides. I get n squared equals 175 divided by 7 is 25. Now I want to get rid of this exponent, so I do that by using a radical sign on both sides of the equation. So the square root of n squared is n. The square root of 25 is 5. So n equals 5. All right, thanks for watching.